Thank you, David. Entonces, now, how you determine that? Super easy. Super easy. Suppose well, let's go to the first example. It's super easy to determine that. Okay, suppose example one. Example one. In example one, we have elementary rational function. F of x equal 2 over x minus 3. Entonces now, how you determine always the vertical asymptote? Well. You take the polynomial and the denominator, in this case, x minus 3. And you enforce it to be equal to 0. Because I know that this guy is 0, 2 divided by 0 is undefined. It's exactly the same idea for the vertical asymptote. Therefore, the conclusion at x equal 3, we have vertical asymptote. Okay, that's it. No, because we have different behavior, no? Number 1, number 2, number 3, number 4. How you do it? Easy. You evaluate before and after 3. Okay, approach it to the left and approach it to the right. But to approach it to the right, I select totally arbitrary value, suppose 4. Because 4 is greater than 3. I'm plugging in. Plugging in is 2 over 4 minus 3. Oh, 4 minus 3 is 1. 2 over 1 is just 2. Entonces, this is a positive value. Okay. When it's to the right, positive value. Okay. Now, when you evaluate, approach it to the left, I select maybe 2, because 2 is smaller than 3. No? So 2 over 2 minus 3, plugging in 2 in the original equation, is 2 over negative 1 is negative 2, and negative 2 is negative. So, according to this conclusion, our graph look like that. Okay, suppose C equal 2. When you evaluate 4, it's positive. Sorry, sorry, mistake. The asymptote is in 3. So, okay. C is 3. C is 3. When you evaluate in 4, it's positive. And when you evaluate in 2, this is 4, and 2 is negative. Okay, entonces super easy. Okay, number 1 step. You take the polynomial at the bottom. You enforce it equal to 0. And you determine the horizontal vertical asymptote. Good, super good. But we have 4 behavior. 1, 2, 3, 4. So you evaluate a little bit after 3, maybe 4, maybe 5, either value, doesn't matter. And 2, 1, 0, negative 1, you evaluate and you obtain opposite sign. So you understand that the behavior is like that. Got it? Sure? Okay. Now, as always, when you analyze something, you verification your work in Desmos. No, I bring the Desmos simulation. And you can see now. Okay, let me share the screen. Boom, 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 and boom. Do you see Desmos now? Yes or no? Answer me.
Yes.
It's super. Example 1. Look at that. Example 1. Boom. I did example 1 here. Example 1 is the function 2 over x minus 3. You evaluate the function n4. Look, fantastic, because Desmos via Misal. Okay. Desmos allow me using function notation. No y. You put a y, you put the f of x. It's the same. Entonces 2 over x minus 3. I do the graph, look. The blue graph. And you evaluate in 4, you evaluate in 2 because I want to approach it to the vertical asymptote, to the right and to the left. I obtain 2 and negative 2. I plot the point. 2, f and 2, 4, f and 4. Is the point. Beautiful. And we determine perfectly the vertical asymptote and the behavior of the function close to vertical asymptote. Any questions so far? No problema. Okay, we are the best. Let's move on to the whiteboard again to see another example. Okay. Okay, switching to whiteboard. Good. This is our. Do you see whiteboard? Yes or no?
Yes, Professor.
Okay.
Yes.
Thank you so much. Okay, let's move on to example 2. Example 2 is similar, it's the same topic as the analysis of the vertical asymptote, but in this case include another new thing. Look, example 2. In example 2, we have the function, the name is g, and g we have binomial in the top. By the way, degree 1, because it's linear. Remember, the degree is the higher exponent in the polynomial. No? This is not important now, but it's important after. So I want to emphasize this idea. And the degree of the polynomial in the bottom is 2. Degree is 2. Because these two indicate degree, no? The higher exponent. Okay. Okay, so what is our goal so far? Well, our goal so far is determine the vertical asymptote, no? Okay, therefore, immediately use present factor for. This is super important, guys. This is the first step always. Well, in the top state, it's just one elementary binomial, but in this case, no. It's a trinomial. It's a trinomial. And the factorization of this trinomial is 3 and 2. Because 3 times 2 is 6. And 3 plus 2 is 5 and negative. Wow, amazing. I like that. Now I immediately can see the factor x minus 3 and the factor x minus 3 is cancelled out. Our equivalent expression is 1 over x minus 3. Anyone follow me so far? Okay, so as always happen, the factor que is cancelled out is considered like whole. Excellent, Villamizar. The factor que is cancelled out is considered like a whole. So we have whole at x equal 3. And we have vertical asymptote at x equal 2. Okay, in other words, in other easy word, the factor gets cancelled out as a whole always, and the factor can stay alive here in the denominator is considered, well, it's considered after you put x minus 2 equal to 0, x equal to, this is our famous vertical asymptote. Okay? Entonces, how look like a graph? Okay, in conclusion, guys, this is the question that every student asks me. Professor, therefore, this expression and this expression are equivalent or no? The answer is yes, it's equivalent, but not 100%. It's equivalent, so it's equal x minus 2. If you consider the restriction que x not 3. Because in 3 we have whole. Okay, another easy word. You can evaluate any value here. Suppose que you evaluate 20. You can evaluate here or here, doesn't matter. The answer is the same. The only guy gets not the same is the 3. Okay, entonces now conclusion, to understand much better, these and these are the same, except in 3. And 3 no, because in 3 behave different. What is the reason that 3 behave different? Because you plug in a 0 divided by 0 times 1, and you cancel out 0. And this is totally illegal. Okay? Okay, so now we are clear. We have a hole in 3 and we have baric acid in 2. Okay, so how I can do the graph? This is another challenge. Okay, the graph look like that. Look. Well, I know in 3. 1, 2, 3. We have baric acid. Baric acid, let me represent like a dotted line. En 3. En 3, no, en 2, sorry. Oh. En 2. En 2 is a baric. Here. En 2. This is 2. This is 2. This is 1, this is 2, this is 3. And this is X axis. And this is Y axis. Okay, entonces, in order to understand a little bit how you behave, for example, in there's a approach to the right or to the left, you evaluate, for example, you evaluate the function G and 1. 1 is left, and 3 is right, but 3 is no good because 3 is a whole. So no good. We evaluate, but no, I avoid 3 because 3, I know that we have conflict problem. Evaluate 4 maybe, or 5, doesn't matter. Entonces you evaluate to the left, you evaluate 0. My recommendation is evaluate close to 2. Is the baric acid. Pero well, entonces you can use it to evaluate G. You can use it. This expression, the complicated expression, the expression at the beginning. Oh, this expression is easier. What do you think? What do you think? We can evaluate in the easy or no? Yes, of course, because this is value equivalent 100%. See, we are not talking about 3. This is the restriction as a whole. And you can, of course you can. Entonces 1 over 1 minus 2. 1 minus 2 es negative 1. Entonces 1 divided by negative 1 es negative 1. So es negative 1. So 1 comma negative 1 is here. I plot that. Boom. Suppose negative 1. I plot here. Bam. And G evaluate in 4. And 3 no, because 3 is a whole. After you evaluate by coins. Entonces and 4 is 1 over, again, using the easy, no? 4 minus 2, okay, 4 minus 2 is 2, 1/2. So in 4, we have 4 1/2. Suppose this is positive 1, the midpoint is 1/2, I plot that point. Boom. And what about 3? Well, you can evaluate 3 in the expression after the simplification. There's 1 over 3 minus 2. 3 minus 2 is 1, igual divided by 1 is 1. Okay, entonces es 3,1 here, but we have whole and 3. Okay, this is the idea. The position of the whole, you determine using the expression after the simplification of the whole. However, si you evaluate in the original expression, no, so you don't see it, it's undefined. It's undefined. Okay, so finally, my curve look like that. I have no idea exactly because we need to study one more thing. This is negative part and this is positive part. Stop here the whole and continue here. I don't know exactly. The rest, I don't know. Remember, we are studying only baric acid. So my goal so far is baric acid and holes. It's my goal so far. I promise. Okay, now we continue studying another most important thing, like a horizontal asymptote, a slant asymptote. We complete the problem with the more information. But so far, the thing you need to understand is the whole vertical asymptote, how you determine the behavior. Remember, we have 4 kinds of behavior, and you evaluate in the right and the left of the potential vertical asymptote, right? But let me conclude the idea. The conclusion is, when you face this kind of problem, the first thing you should do mandatory is factor 4. See, one factor is repeated in the top, in the bottom, well, you cancel out. This factor is cancel out is considered the whole. The other factor can stay alive in the bottom. You put equal to 0 and you determine the veric acid. Okay, okay. I plot the roughly sketch of the graph. I put the vertical line, dotted line, that represent the veric asymptote, no? And you evaluate a little bit after, so right and left. After is right, before is left, and the value of the veric asymptote, que es 2 in this example, no? You evaluate arbitrary point, 1, 0, -1, or 4, or 5, no 3, because 3 is a whole, right? You determine positive, negative. You say I got it, the behavior. Okay, now the representation graphically of the whole, you know, is a circle. You see before a piecewise function, no? It's a circle, and this circle is completely open, no? And you see it's a whole. Any question? Do you follow me? Okay, okay. Let me show you the same graph in Desmos now for you. Okay. Let me share Desmos. Switching to Desmos. You see or no? Example 2. Boom. Look at that. The example 2. Look at that. I copied the original. Look, I copied the original function. Do you see that, right? Answer me. Yes, no. Professor. David, help me. Do you see or no? What's going on? Sweet. Do you hear me?
I see it.
Okay.
I see it. I see it.
Okay. Okay. Sorry. I copy. Look at that. It's interesting because I copy the original. Look at that. This is the original. It's the blue graph. Bam. I flash it to emphasize that this is the graph we are doing. Let me delete that. And also, why not I put G1 is after the simplification. Look, you see get the same graph, except that this graph contains a hole and this not, because the hole I put here like 1 point, you know, I select the color I like. I don't know, I select blue, no, because it belongs to the same graph. And the style is open here. Open. It's selection, blue, and open. Okay. Okay. Entonces, this is one exactly the same, but except in the hole. I suppose that one picture is much better than 1,000 explanation. Okay, you see clear like the water. The whole belong to the original, however, the new one after the simplification have no hole. It's the only difference. Super clear? Super clear or no?
Yes.
Excellent.
Yeah.
Okay, let's move on then to the another thing. Because look, the thing I try to do, guys, is explain the everything theoretical. Okay, so I promise that today, and we continue next lecture, we are doing the full problems that involve everything, vertical asymptote, horizontal asymptote, whatever. Okay, let's move on now to the horizontal asymptote idea. Look. Okay. Horizontal asymptote. Definition. Boom. Okay, super. Okay, let me close that. Let me make it zoom to see more clear. Let me explain the idea behind horizontal asymptote. So we study vertical, now it's the turn of horizontal definition. Okay, look at that. The idea is the end behavior. End behavior. What means end behavior, professor? Well, when the x approaches to positive infinity or x approaches to negative infinity. In other words, is too far to the right, positive infinity, or too far to the left, negative. Entonces now, in this case, you discover that the y value approaches to one specific value I want to call d. Therefore, you can affirm that at x equal d, we have horizontal asymptote. Let me try to understand this. 3 roughly graph to understand this idea. Okay. Suppose horizontal. Horizontal is like that, no? Horizontal asymptote. At y equal d. At y equal d. At y equal d. Okay, this is our y-axis. And different example of the hour curve look like maybe like that. Ooh. Another possibility is like that. Ooh. Horizontal asymptote. Maybe we have vertical and both. In this case, another example is like that. Okay. Essentially is when the x approaches to negative infinity or positive infinity, doesn't matter, positive infinity in behavior, you see the hour curve approaching to the horizontal asymptote, but sometimes not frequently, never touch. The vertical is impossible to touch. The horizontal sometimes touch. Look, in this point touch. And you need to investigate this important point. But this is not the problem. The most important thing I want to emphasize now is when the x approaches to negative infinity, our curve, is the red color, approaches to the horizontal line, but never touch. Sometimes touch in only one point. Okay. Do you understand the idea? Okay, professor, I understand. However, I don't know how you determine. Okay, let's do it. Do an example. For example, example 4, no? This is example 4 of this lecture is determine the horizontal asymptote of that function. Okay, I want to call g is equal 7x squared plus 2x divided by 4x squared minus 3. Minus 3. Suppose que es given, this is an example, no? Entonces now, look. To determine if we have or no horizontal asymptote, the analysis is clear. Analysis of the degree. The degree of the polynomial in the top, the degree is 2 because it's the highest point. And the degree of the polynomial in the bottom is also 2. And when you have the same degree, fantastic. We have same degree. Imply we have what? Horizontal asymptote. Okay, perfect. Now, at what value? This is another problem. Well, and the value is the end behavior. The end behavior. And how you determine the end behavior in one easy way? Well, you're using the dominant idea. Dominant. What means dominant? Dominant is the monomial that increases faster. Okay, actually, we have in our problem 7x squared plus 2x divided by 4x squared minus 3. Okay. Entonces, what is the dominant? What is the dominant? The dominant and the polynomial in the top es obvio que es this guy. Why? Because this increasing faster than this. Professor, I can see the what? No. Roberto Alcalá say que I cannot see the whiteboard. Everyone see the whiteboard or no?
Yes, we see the whiteboard.
Entonces, es your problem. Entonces, recommendation. You go out and get inside again. I can see. Everything I can see. It's your internet problem, no? Entonces, you go out. Sometimes you solve the problems. You go out and you get inside again. Get in. Okay, Roberto. Now, okay, I try to explain, guys. Focusing, concentration, dominant. What is the dominant? Dominant of the polynomial in the top is the monomial that contains higher degree or higher exponent, sorry, que es 7. Entonces, I can estimate Jun at the end behavior, of course. You're talking about the end behavior. And the top we have 4, 7 x squared, sorry. In the bottom, likewise, you take this because 3 is a constant. 3, no increasing, decreasing, is a constant. So 4 x squared. This is the idea for the dominant, guys. Dominant. And now use simplification, this and this, boom, boom, and the answer is 7/4. Entonces, ¿cuál es el super fantastic conclusion? Yes, we have horizontal asymptote at y equals 7/4. Do you understand this or no? Entonces, when you are doing the graph, you put the horizontal line at the value 7/4, no? You put in decimal 7/4. Okay?
Professor.
Go ahead.
I see like a black screen on my end, because even though you're showing the whiteboard, all I see is a black screen on my end.
Okay, let me try again. Okay. I stop sharing. Okay. Now, let me see here. Wait. Now, share screen, select the whiteboard, stop sharing. Okay. Expand. Do you see Yasmin clear? Now?
Yeah.
Yasmin? Okay, super. Do you have any question about this problem or no? Do you understand very well, Yasmin?
Yeah, no, I don't have any questions, but I'm gonna need to catch up on this because I missed out because of how I had a black screen on my end.
Okay. Okay, let me try to apply this idea of determine the horizontal asymptote and two new example I bring for you, and you help me. Suppose example 5 and example 6. Let's do it simultaneously, both because it's the same idea, no? Suppose that function is called h of x is equal ax squared plus 9x minus 5 divided by 2x squared plus 1 And the second example is x squared plus 7 divided by 11 minus x squared. And my question is now, number one, answer me. It's a yes or no question. Do we have or no horizontal asymptote? Yes or no? Okay, and why? Secondly, what value is the horizontal asymptote? Okay? I need help. Come on. Come on. Number 5. We have or we have no? Come on, I'm waiting for you. We have or we have no? Hey, what's going on? What's going on? Come on.
We have no horizontal.
No,
because
why not? Because
it like it's the negative. It's a negative infinity and positive infinity, so they don't have the asymptote.
she said no. Everyone agree or disagree? Total loss? Nobody know anything? Okay, let's see the example 4. The analysis that I did in the example 4 was the degree analysis. What is the degree of the polynomial in the top? And what is the degree of the polynomial in the bottom? What is the degree? Answer me. What is the degree of the polynomial in the top?
2. 2 and 2.
2 and 2. However, when it's the same degree, the answer is yes. No, we have horizontal asymptote. And end the story. We have one. Got it? Got it? Okay, this is not this is not too easy. I try to explain step by step. I agree. Okay, Victor. Slow down. So you are doing to determine if we have or no horizontal asymptote. You determine the degree of the polynomial in the top, determine the degree of the polynomial in the bottom. See if they say yes. The answer is yes. Definitely. At what value? It's the second question. At what value? At what value? At what value is our horizontal asymptote? It's a y equals something. How you determine this? You apply the idea for the dominant. Who is the dominant, guys, or monomial in the top one? In the top. Dominant in the top, dominant in the bottom. It's super easy because you take the monomial that contains the higher exponent. It's 8x squared divided by and 2x squared. Es obvio que x squared cancel and 8 divided by 2 is 4. And y equal 4 is our famous horizontal. Any question? Do you understand or no? Answer me, please. Are you clear or confused? Because this is complicated. I promise this is just the beginning. I promise I want to complicate more. No, I don't want. Pero it's a mathematics. It's a call. Okay. Who helped me with the second example? Example 6. Who helped me? The answer is yes or no. We have horizontal.
Yes.
Yes.
Super. Because it's the same degree.
Exactly. Degree of this guy is 2. Degree of this guy is 2. She said yes. Amazing. Entonces, now, at what value? Is the second question.
1.
1?
Because 1 x squared and 1 x squared. 1.
It's 1. Everyone is agreed it is at y equal 1?
-1.
-1. Very well. I put intentionally to confuse you. Okay, what is the dominant guy in the top? The dominant guy in the top, where do you get the degree from? Gabriel, look at that. Gabriel, degree by definition, Gabriel, is the higher exponent in the polynomial. Look, this is my polynomial, x squared plus 7. The exponent, well, the only exponent we have is 2. But in general, it's the higher exponent. Higher exponent in the polynomial. Exponent. Suppose you have 3 x to the 4th power plus 7 x to the cubic power plus 8 x to the 2nd power plus 9 x plus 100. What is the degree of this polynomial? What is the degree of this polynomial? Where is the guy can ask me? 4. 4. Where come from this 4? This is. Got it.
The highest one.
Super. Okay. Let's focus again in our problem. What is the dominant expression in the top? It's x squared. I negligible. So I ignore totally 7. 7 is constant. And what is the dominant monomial in the bottom? Is negative. X squared, right? So this is cancel out and the answer is 1. Oof, super. We are the best. You understand this? Okay. And that's it, no? Unfortunately, no. We have another case in which we have horizontal asymptote. Let me explain another case. Okay, let me explain another case. So we are clear so far. Okay, when the degree is the same, we have good. We have horizontal asymptote, but unfortunately, we have one special case. A special case, and we have also horizontal asymptote. Now be careful, because we have two cases. The regular case, que when the degree is the same, que the most frequently you can see in the example, but we have another. Suppose this example, suppose the function h of x is equal 5 divided by 4 x squared plus 9. Suppose that function. Divided by 4x squared plus 9. Okay, we are doing the same analysis of the degree. Degree of this polynomial is 0 because we have no x. However, degree of this polynomial is 2. So in this case, happen that the degree of denominator is greater than the degree of numerator. In this case, it's greater than 2. So the degree is greater than 1. It's the same. So it's just greater than. So yes, we have horizontals, but special. Okay, always the special is at y equals 0. And the reason is clear. Because the degree, so this polynomial increasing faster than this. This is more, actually, this don't increasing, it's stay constant. But suppose que it's x increasing, but this increasing faster. And when you divide one thing increasing, divided by another guy increasing faster than, it's obvious that the total quotient is going to the 0. Okay? It's clear or no? It's clear or no? I can explain in another way. It's clear or no? Okay, listen to me. So you understand, don't let me waste the time with another extra explanation. This is clear or no? Suppose reciprocal function. Reciprocal.
Yeah, it's clear. If the degree of the denominator is greater than the degree of the numerator, you're having a horizontal asymptote as y is equal to 0. It makes perfect sense.
But okay, Debbie, it's okay. But you understand why? The reason?
Because it's a rule, that's all.
Let me try. Quickly explanation. Suppose a reciprocal function. Is one particular example. It's clear to see this idea. Reciprocal 1 over x. Yeah, I want to evaluate when 1 is constant. Never change. Yeah, I want to increase in x. Suppose x at x equal 1. 1 divided by 1 is 1. Okay. Suppose at x equal 10. 1 over 10 is 0.1. Okay. Suppose at 100 is 1 over 100 is 0.01. Suppose 1000 is 1 over 1000 is 0.001. Do you see it is decreasing, and approach to what value? At what value approach it? See, I continue increasing 10,000, 100,000, 1 million. At what value approach it? At what value approach it? Answer me.
0.
0. It's exactly this conclusion. Boom. Super clear now? Super clear now? So no answer, I suppose que yes, no? Okay. So now I bring another example. Okay. What is the I finished the explanation? No. So far, the only possibility that we have to determine horizontal asymptote is doing the analysis of the degree. So we have two possibilities. Same degree, yes, we have. This is ordinary case, the most common case. When the degree of the denominator is bigger to the degree of the denominator of the numerator, yes, it's special. Entonces now I'm going to find the value of the horizontal asymptote. There's a special zero, for sure, always. When there's no special, it's an ordinary, entonces you determine the dominant monomial at the top and the dominant monomial at the bottom. And you divide, and that's it. And the value gets the horizontal asymptote. What is the new idea behind this? Well, the new idea is that sometimes you need to determine where a graph of the original function, of course, cross it a horizontal asymptote. This is a new idea I want to discuss it now. Okay. Our graph not always cross it a horizontal asymptote, but sometimes happen, seldom happen. This is an important point. And you don't forget this. The student frequently forgot this idea. Suppose this example. Suppose h of x equal 8x squared plus 9x minus 5 divided by 2x squared plus 1. Okay, question number 1. We have horizontal asymptote, yes or no? Boom. Where's the answer? Help me, guy. Quickly, yes, no?
I believe we do.
Yes. Okay, why?
Because it's the same degree.
Super. She said, because they have same degree. Super good. Okay. At what value? It's the same question. At what value? Is the same, the next question. At what value? So you apply the idea for the dominant, no? This is approximately in the end behavior. And the end behavior. What is the dominant guy in the top?
The x squared, the 2.
Pero include A, of course, no?
Right.
You mentally.
8 divided by 2 is 4.
Oh, excellent. She said que 4. Okay, entonces, our value at y equals 4 is our famous horizontal asymptote. Everyone is agree? Everyone follow me? Do you understand this idea? This is easy. It's only memorize the rule. And the rule is the degree analysis, number 1. And number 2, the determination of the end behavior in the top and the bottom. That's it. Another shortcut to do in 1 second is you take leading coefficient here and here. End the story. Okay, all right. The new I want to discuss it is if the graph crosses the horizontals. To investigate that, well, you take the original function is given. And you enforcing to be equal to 4. Because I want to investigate if this function, the y value of this function, I don't know, sometime or at 1 point is equal to 4. Okay. So now you have in your paper now 1 equation, and you solve this equation. I propose doing the cross multiplication. You multiply ax squared plus 9x minus 5 times 1, stay the same. Equal 4 times 2x squared plus 1. Everyone follow me? Algebra? Okay, you distribute it now. Distribute it now. It's ax squared plus 4. Wow, look at that, what's going on. The ax squared and the ax squared cancel out. And stay alive, 9x minus 5 equals 4. So for x, linear equation, 9x is equal 4 plus 5. 4 plus 5 is 9. Divided by 9. Divided by 9 is obvious that x is 1. If you get 1 answer, it's because, yes, my graph crossed the horizontals. Sometimes you see another example que no. And the reason que no is because this equation have no solution, no? Okay, entonces, what is the famous point? What is the famous point in which our graph cross the horizontals is at the point 1 comma something? And what is the y component in this case? What is the y component in this case? Huh? Tell me. The thing I am doing is determine if my function, my complicated function, my rational function crosses or no the horizontal asymptote que es y equals 4. I put together, I solving, I determine the x value, x equals 1. But my question now is, what is the y component of this point? This is the ordered pair, 1 comma something. And this something, what value is? Question mark. What value is? Come on, come on. Answer me. No idea. Totally lost, everyone. Okay, Noel. And Lan.
I'm sure there's a rule to it, but I forgot the rule.
No, no rule. Common sense. No rule, common sense. Nobody. Wow.
0.
4. Es obvio que 4. Es obvio que 4. Because it's exactly the same. I am looking.
That's right. Okay.
It's 4. Okay. The famous point is the point 1,4. Always is the same. No rule. Okay. It's 1,4. So the guy gets unknown is the X component. The Y I know at the beginning is this. Robotic code. Okay. Okay, clear or confusing? I promise. I promise that we see several examples of this. This is the first idea I present today. However, today we are doing maybe 1 or 2 examples. We continue doing next lecture more example. And we continue doing in the review packet more. Okay? But you need to remember the rule. This is okay. Let's move on now to another kind that fortunately is the last kind of asymptote. It is the slant asymptote. Boom. Slant asymptote. We study now slant asymptote. Okay, so remember, we have 3 kinds so far. Well, that's it, no more asymptote. We have vertical asymptote, horizontal asymptote, and slant asymptote. Okay, it's the new one, okay, we study now. Okay, slant asymptote occur when the degree of the numerator, so degree, so there's similar analysis, degree analysis. The degree of numerator is equal degree of denominator plus 1. Okay, another easy word to understand when the degree of the numerator is bigger. But no bigger than 2, 3, 4, 5, no, only 1. Example to understand more clearly. Suppose f of x, this is example 7, I guess so. F of x is equal x squared plus 1 divided by x minus 1. I have no idea. So I am doing the degree analysis. The degree of the polynomial at the top is 2. The degree of the polynomial at the bottom is 1. So the degree of the numerator is greater than 1. The degree. Entonces, in the conclusion, we have a slant. We have a slant asymptote. Okay, it's important to understand that this is completely mutually exclusive. Okay, what is the idea? The idea is we have horizontal or we have slant, not both. So mutually exclusive. See, we have horizontal, don't analyze anything about slant because it's impossible. It's mutually exclusive. And so you have slant, we have no horizontal. Vertical, no. Vertical is universal. Okay, we have both. Maybe in one example you have horizontal and vertical. Good, it's possible. And we have, why not, a vertical and slant together. It's possible. This is okay, and this is okay. Look, this is not okay. Is that we have horizontal and slant. This is impossible. Okay, mutual exclusive. The challenge is, okay. What is a slant? The slant You know, so far, the asymptote we are studying so far is vertical, like that, boom, 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 vertical asymptote. Horizontal, like that, bam, 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 horizontal asymptote. And slant asymptote is a line. It's oblique line. Maybe it's low positive or it's low negative. So how you find that? Well, the equation for the line is y equal mx plus b. You know very well in elementary algebra, intermediate algebra. Okay, so now my goal to find this equation of the horizontal no slant asymptote, sorry, is you are doing long division. So first of all, identification. Yes, we have slant. But what is the equation for the slant? When you are doing long division. Long division between numerator and the denominator. And you are doing using the long division format. Okay, you put the numerator inside the box. You put x squared. My highly recommendation is complete the degree. So we have missing in the numerator the term can contain x, so degree 1. In order to doing well or no well, you know, more clear, you complete the missing guy using 0, because it's important. Because when doing the long division, you divide a multiplication and subtracting by column. So it's important, the organization. Entonces now x minus 1 is the divisor. Dividend, divisor, and we start long division. Exactly the same we are doing in intermediate algebra. This is x. Because x times x, look here, is x squared. I'm subtracting negative. Okay, division is a procedure que es the algorithm, que es basically multiplication and subtraction, multiplication and subtraction, multiplication and subtraction. This is the algorithm of the division. And likewise, in multiplication, x times -1 is negative x, but by subtracting, you change the sign. This is cancel out. This is the intention. This is x plus 1. And stop here. No. Why no? You stop the division of the polynomial when the degree of the remainder of the potential remainder is smaller than the degree of the divisor. Degree of the divisor is 1. And this is x plus 1? No, it's the same degree. Therefore, we cannot stop. We continue. So say it's 1. Now let me see. It's 1. Yeah, it's 1. It's 1 because 1 times x is x, subtracting, change the sign, and 1 times -1 is -1, subtracting is positive. This is cancelled as always, and the remainder is 2. Okay. Therefore, after the long division, I can affirm that our original expression is, let me copy here, x squared plus 1 divided by x minus 1 is equivalent 100% to the quotient, que es x plus 1, plus or minus, depending on the sign here, is 2 positive, remainder divided by divisor. Okay, guys, this is algebra. This is basic algebra, long division. Allow me decompose this expression and this expression. So this expression is easier to analyze because that part should represent our slant asymptote. Y equal x plus 1. Okay. And that part, well, that part represents the rest. And by the way, I can see using my eyes, here we have vertical asymptote at x equal 1. Okay? Because 1 minus 1 is 0, no? Undefined. Okay, entonces, okay. Now, see, I want to have some idea how it look like our graph. I always recommend this, no? Pero, okay, suppose que I'm in the jungle, we have no Desmo, we have no internet, okay? So now one possibility is, well, you plot the slant asymptote and the, well, okay, and the vertical. The vertical is easy, N1. The vertical is like that. I'm using blue color. This is the vertical asymptote at 1. And the slant, the slant is, I compare this and the classical formula. Everyone knows it's mx plus b, no? It's obvious que m es 1 and b es 1. It's a coincidence. So m is coefficient from the x and b is the constant. So 1, 1, that means que the Y-Intercept, this line is in 0,1 here. 0,1 because b is 1. And the slope is, this is a slope, and this is the Y-Intercept. I suppose you remember very well this. It's 1, entonces on, from this point, I go over, because of positive, 1 unit, and to the right 1 unit. And you determine the second point, by the way, it's 1,1. And you connect it. This is our slant. Slant asymptote, important. And it's a vertical asymptote, important. And we have horizontal. Of course, no. No, because it's mutually. And the rest, using our imagination and using additional point or using another technique I want to explain after that, you are doing this. This is our curve. Look like that. Okay, approach it, but never touch. Okay, slant is possible to touch. No. You never see examples. This is very, very complicated. Do you understand the idea for this slant? Okay, I bring another example of this slant to practice a little bit long division, because maybe you don't remember identification, if you have a slant or no. Okay, another example. So far, it's okay. Everyone follow me, good or no good? Or you are in big trouble. Come on, guy, opinion. Opinion.
Follow.
Okay. Okay, another example of this. I want. Good. All right, example 8. I call example 8. Example 8. Okay. Suppose that function is called G. Is 2x squared minus 5x minus 3 divided by x minus 2. Okay, question 1. We have horizontal asymptote or vertical or slant asymptote. Question 2, where? To answer that question, I need to do the degree analysis. Okay, what is the degree of the polynomial in the top? Degree.
2 and 1.
2 and 1. So what do you think, Miss?
Slant.
Slant, for sure. She said, slant, professor, slant. Horizontal, no. Totally discard. To determine where is more complicated, because I need to do the long division. See? 2x squared minus 5x minus 3. Bye-bye. X minus. Putting off the microphone, miss. So now long division. You multiply by 2x, because 2x times x is 2x squared. By subtracting, you change the sign. And 2 and 2 is negative 4. X by subtracting, you change the sign. Okay, as always happen, this is cancel out, and this is -x minus 3. I continue the division because the remainder now is degree 1 and the divisor is degree 1. We continue until you get 0 degree. So says -1, -1. How do you know get -1? Because -1 times x is -x by subtracting your chain sign. This is +4 by subtracting, +2, sorry, by subtracting as negative. And the answer is -5. This cancel out, and the answer is -5. So our expression. Let me erase that part because I know that you know very well that part. Our expression so far is equivalent to say 2x minus 1, is the quotient part. -5 is the remainder part divided by x minus 2. Ah, amazing. I like that. This is equivalent expression, right? And you can see clear now that this part is our slant asymptote. Our slant asymptote is 2x minus 1. Okay, I do the graph of this. This is super easy. This is the intermediate order, and also this is the slant asymptote equation. And by the way, I discovered okay, we have a vertical asymptote at x equal to. Now, see, we are doing the graph roughly without decimals. No. Is something like that. XY. Okay, and 2, we have a vertical asymptote. This is our vertical asymptote. And the slant is y equal to x minus 1. Immediately in my mind, I compares with the mx plus b. I discovered que m is 2. Que es the coefficient from the x is a slope. And b is -1. It's the y-intercept of this line. So I plot that. I plot a -1 here. This is 0, -1. And the slope is 2. 2 positive is over. So my line is going up. So it's 2 units, and okay, rises 2, and wrong is 1. Boom. I plot that point. I connect it, and this is my slant asymptote. End the story. And the rest, I want to explain how do you determine this. See, it's like that, see, it's like that. I promise in the example we're doing now, I explain in detail the rest of the story. We focus it always now to determine the slant. Are you strong in that part? Are you strong in that part? Let me know, please. Slant asymptote. No? Wow, what's going on? Are you
I think we all got it.
Okay, David says it's okay. A ver, opinion, guys. Noel, of course, we need practice. Okay? Entonces, okay. This is online class. It's NDC Live. Okay? When I planning, when I design that course, I posted in Alex, no? The example. This is the example that you need to do by yourself, no? However, in the review packet, we continue doing something, no? But so far, don't be scared because too many rules. I know, I understand, but it's no big deal. So you understand where I come from this rule. I suppose it's easy to understand this. Okay? Okay. Okay, entonces I want now to explain in detail the rest. What is the rest, Professor? Well, this is I call different, this is procedure, step by step, to graphing a rational function. Okay, listen to me, this is the most important moment in our class today. Okay, what is the idea? The idea is graphing a rational function. Okay. 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 The first step always. The first step always is they are polynomial with no common factors. Let me explain in detail what I mean that. Okay, you have a rational function, R. And by definition, rational function is the division two polynomial, P and Q. And this is synonym to say you express it in factorial form. Factorial form. Okay, in other words, is factorization P and factorization Q. So in this moment, see one factor is cancelled out. This is the reason that no common factor. You cancel out. Cancel out. The factor is gone is considered a whole. So you determine the potential holes or no. The most frequently situation that happen is we have no hole. All happen, seldom happen. However, you continue after this step working with not the original functions, the new one after the elimination the holes. But in your mind, you remember that we have a hole at the point, I don't know, 3, 4, 5. Okay? So far it's okay? Anyone follow me? I see in the example, I bring a lot of examples to illustrate this idea, step by step. Number 2 step, actually it's 7 steps. 7. Number 2 is find super important point. Okay, is the Y-intercept. What is the formula for finding the Y-intercept? Evaluate the function and see. Let me call here no R. Let me call F. That's the way it is so far we have called F. This is the original function. You evaluate the function in 0. It's just plugging in x equals 0 and that's it. So plugging in x equals 0 and determine the y value associated with this. Okay, so the point is 0, y. The y that you obtain after the plugging in and compute. This is easy, right? Number 3 is find another important point is the x-intercept. This is more complicated because it's f of x equal to 0 is the mnemonic divide to remember. This is the formula, guys, of the y-intercept, and this is the formula for the x-intercept. But in this particular example of the rational function, I know que es the division to polynomial. And to be 0 means it's equivalent to say that the top part is 0. Wow! Yeah, I don't care the bottom part. It's totally irrelevant. No important. So you take the top part equal to 0 and solve this equation. And the value of this, suppose, no, always we have 1, sometimes we have 2. Suppose that we have 2 values, no? Entonces, x1, 0, and x2, 0. Is the value x that you obtain when you solve this equation. Suppose that sometimes happen gets only 1 value, sometimes no, sometimes happen get 2. It's the most frequently we have it. Everyone follow me? Number 4, important moment is determine the vertical asymptote. I put in plural because sometimes you have not only 1, you have maybe several vertical asymptotes. So what is the formula, professor, for finding the vertical asymptote? Okay. You take the polynomial and the top and the bottom Q after the simplification of the whole, no hole anymore. No. You put in force it to be easy, and you solve this equation. And the result of this equation, suppose is one solution, two solution, suppose two solutions, x1, x2. So we have two baric acid. Baric acid number one and baric acid. See, we have one solution. It's because we have only one. Number 5 is the determination horizontal asymptote or slant. Entonces we are doing the analysis of the degree. Degree analysis. I don't want to repeat again. I repeat, but repeat in the specific example. Degree analysis. See, it's the same degree. No. I don't want to repeat. It's the same degree, or when the degree, the denominator is bigger of the numerator. And slant is only when the degree of the numerator is greater than 1, the degree of the denominator. And remember, so they are mutually exclusive. See, we have horizontal, we have no slant, and see, we have slant, we have no horizontal. So we have only one possibility, not two. It's impossible to be both. Okay, number 6 is super important. Yeah, I want to explain why. It's the test of symmetry. I take advantage. Symmetry. I take advantage the transformation that you know in the test, in the chapter 2, no? So remember, we have 3 kinds of functions. We have the even function, we have the odd function, and we have the neither function. So what is important, Professor? Well, it's important because you determine it's even. Okay, determination of the even is super easy. You are doing the reflection. See, the reflection you obtain is the same, doesn't change. It's because it's even. Entonces, si es even, look, suppose que you're doing the graph. And you, see, you determine it's even. Correct, I got it. So that means when you select one value of the x, suppose 4, and you plug it in the original function, I suppose hypothetically, okay, the answer is 20, the y value, the point is 4,20. I don't need to do -4 because the answer is the same, because they are even function. So you spend 1 minute doing the analysis of symmetry, you save a lot of time because you determine it's even. Well, you focus only in the positive part of the x, because I know that the x negative part is the same because they are even. Okay. However, when you are doing the reflection and you get the opposite sign, is the idea for the odd function. Well, it's also another kind of symmetry because when you evaluate M4, suppose it's 20, and you evaluate -4 and -20. So that point is -4, -20. So this is the idea for the odd function. Okay, so I take a bunch. Spend 1 second or 1 minute to analyze the symmetry. See, symmetry, maybe even or odd, you don't need to do the positive and the negative. You focus on the positive part. You know, si es even is the same sign, si es odd is opposite sign. And neither no symmetry, no symmetry. We have no symmetry. So unfortunately, we need to do the positive and the negative part completely separately. You have 2 problems, no 1 problem. Do you understand the importance? I don't care. No, it's important. Okay. And finally, the number 7 step, and number 7 step, is compute and plot additional point. Additional point. Okay, professor, I understand, but how many additional points? Well, this is not rule. This is using your common sense, using your imagination. However, I want to give you now a basic rule, no? Okay, that depending of the partition of the x-axis. Look. Suppose one hypothetical example. Okay, we determine here, this is x-axis, y-axis. You determine, for this is 0,0, no, the origin. You determine 2 and 4, we have in 2 1 x-intercept. So my curve passing through 2,0, and here no, and here we have vertical. Okay, in the negative part, we have another here, a -1. We have another vertical asymptote, and we have maybe a -2 and -3. One another x-intercept, -3,0. Okay. So now, how many additional? Well, additional, for example, you select 1 here, 5, and you evaluate the original function 5. This is easy, just plugging in arithmetic. You, for example, select another guy in between 4 and 2, suppose 3. And you evaluate it. You select another in between 2, no 0, no. Well, you want 0, or in between 2 and -1. So in between the 2 asymptotes, 2 vertical asymptotes, or 1 vertical asymptote and 1 x-intercept. Well, in this case, why not? I select 0. 0 is I like so much because it's easy, right? And one more guy in between -1 and -3, suppose -2. And finally, one after -3, que es -4, -5, -7. Okay, -4. Okay, this is the minimum amount of point that you plot. You want to select more, much better, more clear. And also remember that we can use in decimals. Any problem that we have. Super. Do you understand the basic idea? Don't worry because you practice now. Practice. Yeah, I reinforced this idea several times. This is the famous 7 point. We need to analyze the graph of the rational function. Okay. The rest of the time, let's move on to the first example. Maybe we don't finish today. We continue doing next lecture. Okay, it's example 9. Very important. Example 9. And you guide me, step by step. 7 steps. Wow. Example 9. Complete example using the 7 step. Is the function is given is f of x is equal 4x divided by x squared minus 4. And the question say, do the graph. We are doing the graph by hand. And also, why not? We are checking with decimals, of course. Okay, so I don't remember anything because you guide me. Step 1. What is the step 1 in the guideline that we studied before? What should I do? What should I do? What should I do? What should I do? In the step 1. Come on. Participation. I need participation. I am boring to do by myself. Okay. Come on. What is the first step? You Checking your note. And the note say they are polynomial with no common factor. Factor 4. Very well. Roberto Alcalá said factor 4. Okay, Roberto. Entonces now in the top is a monomial. Stay the same. However, at the bottom we have binomial, and this is special binomial. It's the difference of a square, and the factorization is xx 2 plus or minus. Boom. I suppose that you remember very well this formula in intermediate algebra. In our particular example, A is x, B is 2. I suppose that you remember this. I don't want to copy this stupid thing. You remember very well. Okay? No problema. Okay. Entonces I have a question. We can cancel out something or no? We can cancel out something here. One factor in the top and the bottom is the same. You can cancel out? No. No. So what is the conclusion? The conclusion is, in this example, at least, no whole. Okay? Super. What is the second step? What is the second step? Come on, I'm waiting for you. What is the second step? What is the second step? Determine what?
Find the Y-intercept.
Super. Y-intercept. And the formula to find the Y-intercept, you value the function and 0. Plugging in. Plugging in where? In the factor 4 or in the origin. Either way. 4 times 0 divided by 0 squared minus 4. 4 times 0 is 0. 0 squared is 0 minus 4 is minus 4. And 0 divided by any number is 0. Oh, entonces now the point 0, 0 is our Y-intercept. And when this situation happens, it's because they are coincidence between, when there's 0, 0, it's the origin. They are coincidence with the Y-intercept and X-intercept. Just in case, I want to verification in the step 3, the X-intercept. And remember, basically, to investigate the X-intercept, you take this is equivalent to say, you take the polynomial in the top, I don't care, the polynomial in the bottom is not important now, in that step, equal to 0. You solve this elementary equation, divided by 4, again, we get x equals 0, they are perfect coincidence. This guy is both, is Y-intercept and X-intercept. This is not good. The good is that we have more point. More point is much better for us because we have more information. Si son is repeated with the same guy, it's no good because we have so far the only thing information that we have is that we have only 1 point, que es 0, 0. Okay, I understand. The step 4. This is a crucial moment. This is the inflection point. Because this give me information, how look like a little bit, our graph. Okay, vertical asymptote. And what, Professor, what is the formula to determine the vertical asymptote? Well, you take the polynomial at the bottom, Q equal to 0. This is the formula. Look, I copy the formula here. I copy the formula here. I copy the formula here. Okay, now, do you prefer doing it in that way? Or you prefer doing it in that way? Either way. So you take the original, or you take the factor 4. My question is, my answer is, it's the same. But either way. So you feel strong solving this quadratic equation, it's okay for you. X squared equals 4, apply square root both sides. X is equal plus or minus. Bam. Do you feel strong? By factorization, you have two linear equations. Equal to minus 2. And x minus 2 equals 0. X equal to. And we get exactly the same. verticals. That means in our problem, que we're solving now, we have two verticals. Entonces, these guys, I don't know why. So vertical asymptote 1 is at x equal to, and vertical asymptote 2 is at x equal -2. So I say in this moment, in my mind, I don't know, not necessary for you. This is a moment I try to start doing the graph. When you have the vertical asymptote in my hand, it's a crucial moment. For a moment, well, yes, why not? I put a y-axis. Okay, entonces en 2. 1, 2. 1, 2. Negative. And we have here one vertical asymptote. I have here another vertical asymptote. This is vertical asymptote 1, I call. Vertical asymptote 2, I call. And don't forget the most important point of this, is 0, 0. Okay, by the way, is X-intercept and Y-intercept. Do you see that? Do you see that? So far, follow me? Good. We are doing good. Number 5. Well, number 5 is the analysis of the horizontal or slant. Okay, I come back to my famous function, que is 4x divided by x squared minus 4. Okay, and to analyze if we have horizontal or slant, well, you analyze the degree. The degree of this polynomial is 1. The degree of this polynomial is 2. Okay, so my question is, we have slant, we have a horizontal or slant, or I have no idea. Our value, I don't know. What should I do? Help me. Okay, any help? I'm waiting for you. The time is almost over, but I need to finish at least that part. And we continue doing it again. Next class. Okay. It's important for me that you participate and try to help me see we have no horizontal or slant, or I don't know, analysis of the degree. What do you think? Come on, Juan Gómez. Juan Gómez, Kendrick Crespo, Lariap, Gabriel, Nicole, no idea. Are you lost? María Covarrubias. Do you hear me? Sebastian?
Yes.
You have no idea? I understand. Okay, you understand, but try to answer my question. Gabriel said, I understand. But what is it? We have a horizontal or we have a slant? Or yeah, what value is? And Edgar Quintana.
It's horizontal.
Horizontal. How do you know the horizontal?
Because like degree 1 smaller than degree 2.
Super. We have horizontal. Yes. No, it's not. What value, Miss? Y equals something. What value?
Y equals 0.
Y equals 0. Because it's a special case. No regular case. Because the degree of the denominator. Super good. I feel it. No. Because I need to determine. It's important. The student forgot every day. If the curve is our curve, cross it on all this. To investigate this, you take the equation of the hour function and you enforce it to be equal to 0. Okay? Well, this equation I solved it before because it's by coincidence, something happened, not always, but something happened. It's exactly the idea that we are using in the X-intercept. And the solution is, yes, we have solution at x equals 0. So x equals 0 is the super famous point que is X-intercept, Y-intercept, and also is the famous point in which our horizontal asymptote is at 0. So the formula, the equation, this is a horizontal asymptote, y equals 0, coincident with the x-axis. Okay, this point is crossed also. Let me put in red color because when I finish the problem, I do the graph in red color. No? Okay, the equation, by the way, the equation for this vertical line is x equal 2. The equation for this vertical asymptote is x equal -2. Remember, when this x equal a number, it's a vertical line. When this y equal one number, a horizontal line. Okay, guys, time is over. We continue Wednesday. This problem and two more important and complicated graph of the. Okay. I stop recording.